Thank you for watching this Hexagon Geospatial e-training module, Zonal Change with ERDAS Imagine Part 1, Creating Your Project. In this module, we'll create a zonal change project, save it, and run the process. In subsequent modules, we'll see how to analyze the results and generate a report. Change detection is used to highlight or identify significant differences in imagery acquired for the same area at different times. This information often plays an important role in the life cycle of GIS features and provides the capability to update data based on new imagery. Examples include natural disasters such as flood events or earthquakes, urban development, and natural resource management. The ERDAS Imagine semi-automated zonal change detection tools save time by calculating the likelihood of change within defined zones. The likelihood values indicate how likely the zone has undergone change: very likely, not very likely, or somewhere in the middle. Using the calculated change likelihood values as a guide reduces the human interaction time across the entirety of the area while maintaining accurate and valuable results. Always remember that the results of any digital image change detection process are largely determined by the quality of geographic correction and overall image quality. Always use two images that have the most similar characteristics as possible. This includes the season, time of day, and atmospheric and ground conditions when the imagery was captured. In addition, the images should have similar spatial, spectral, and radiometric resolution. Let's open ERDAS Imagine and see how to create the zonal change detection project. Start by opening the change detection layout in the ERDAS Imagine workspace. A layout is a predefined workspace designed to streamline tools relevant to a specific workflow. Click the File button and select Layout. In the Layout pane, select Zonal Change Layout. The layout opens to a configuration of two 2D views: the Contents panel and the Change Likelihood panel, and the Review and Process tabs. The Home tab and Help tab are also available. Note that on the Home tab, the tools that are available are tailored to the needs of a change detection project. First, we'll define our project. Click the Process tab. In the Project group, click New. In the File Selector dialog, navigate to a directory to store the new project. For this example, name the project Change. The project file will have the extension ZCP for Zonal Change Project. This file saves pointers to all the data, including imagery and vector data, and defines settings within the project. When reopened, your project will reload just as you've saved it. This makes it easy to come back to your work or share the project with others. Click OK to create the project. Now we'll define the images to use in the change detection process. First, define the older image. This is the before image, or the image captured at the earlier time period. From the Project Properties group on the Process tab, click the Before button. Navigate to your images and select the older image. For this example, the Villages subset 2007.ecw, and click OK. The image loads into the view, and you can see the image name in the Contents panel. Now load the newer image, which is the image that was captured after the first image. From the Process tab on the Project Properties group, click the After button. Navigate to your images and select the newer image. In this example, the Villages subset 2008.ecw, and click OK. Again, the image loads into the view, and you can see the image name in the Contents panel. The 2D views are geographically linked to display the same view center coordinates. As you zoom, pan, and roam throughout the images, you will maintain the same view position in the other viewer. Next, define the number of zones that you want to partition the study area into. Each zone will undergo change detection and have a calculated likelihood of change. You can define an explicit number of grids, or you can load an existing zone file dataset corresponding to your study images. In the Project Properties group, click Zones, Zone Files. Navigate to the existing zone file, typically a vector file such as a shapefile. In this example, the Villages Parcels subset.shp, and click OK. The zone dataset loads into both views. Notice in the Contents panel that the same shapefile layer is now listed in each view, and we can see the green outline of the shapefile layer in the view. Also notice that in the upper left, the Change Likelihood rank panel is now populated with a list of zones. In the bottom of the